look at another example relating to sampling distributions of the sample mean, and this one is involving the distribution of sample means of call center wait times. This is really similar to number 21 in section 8.1. Not just that number, it's really similar to most of the problems you'll see in the homework, but in particular number 21. So the wait times of customers who call customer service at Prime Health Insurance are normally distributed with a mean of 10.4 minutes and a standard deviation of 3.2 minutes. Part A, what's the probability that a randomly selected customer waits for more than 12 minutes when calling customer service? So we want to find the probability that X is greater than 12. This part A is actually just exactly the same as what you would do in chapter 7. Notice that there's no mention of a sample mean or a sample. They're just talking about selecting one randomly selected customer. So just like what you would do in chapter 7, you could use a graphing calculator as one way to solve this. If you wanted to draw a normal curve, you could. We want to find the probability the customer would wait for more than 12 minutes. So on the Casio calculator, 12 would be your lower bound, that's the left boundary. Infinity is your right boundary, the upper bound. The standard deviation given in the problem was 3.2, and the mean in the problem was 10.4. So that's just given as your mean and standard deviation. On the TI calculator, again you would use normal CDF, put in your lower bound, upper bound, mean, and standard deviation. And either way, you should get a result that's 0.3085. The other way to work this out is using a table. First step, never hurts to draw out a normal curve. Calculate the z-score. This time, since this is not involving a sample mean or a sample, it's just that old z-score formula from chapter 7. Plug in all the numbers, 12, the mean, the standard deviation, and you get a z-score of 0.5. So we've converted our probability so that it's no longer in terms of x, but now just in terms of z. We'll go down to table 5, look up a z of 0.5, so here's 0.50, and lines up at 0.6915. But remember that if this is our z at 0.50, that 0.6915 represents the area on the left side. And in this problem, we were looking for the area on the right side. So to get that area, we'll do the complement. We'll do 1 minus 0.6915. And so that's going to be 0.3085. And that's written right here. We do all that, we do the complement, we get 0.3085. part B of this problem is asking for another probability, but notice now it mentions taking a sample and it mentions a mean. So it says, what's the probability that a random sample of 10 customers results in a mean wait time of more than 12 minutes? So this time we're not just dealing with X, not just one customer, but we're dealing with X bar, the mean of 10 customers. Before using the calculator method or any of these methods, we'll have to figure out the mean of the sampling distribution and the standard deviation of the sampling distribution. Because all of this mention of samples and means means that we're dealing with a sampling distribution. So to start, we'll need to find the mean of that sampling distribution. The mean of the sampling distribution is just the population mean, so 10.4. The standard deviation of the sampling distribution is the population standard deviation divided by the square root of the sample size. So 3.2 was the population standard deviation. Going back to the description in the problem, that was the population standard deviation. And then n is 10. It's saying that we're taking a sample of 10 customers. So when you put those in, it comes out to about 1.01 minutes for the standard deviation of the sample means. Now that that calculation is done, we can go on to the different methods. And these methods again are the same as what we've done in all of these videos and in Chapter 7. We could draw the curve if that helps out. We're trying to find the probability that we get a sample mean now of more than 12. So in the Casio calculator, get to NCD, 12 is the lower bound, infinity is the upper bound. The mean is still 10.4, but notice that this has changed. In part A, this was 3.2, but for the sampling distribution, now it's 1.01. We had to calculate it as being 1.01. So put all those numbers in. For using the TI, use normal CDF, put in all these numbers, but this is the only difference. 1.01 is our standard deviation, and it comes out to about 0.0566. Of course, you could work this out using a table. You could start off by drawing the normal curve. If that helps. Now we'll use this z-score formula because we're dealing with sample means. Plug in the 12, 10.4, 1.01 for our standard deviation, and the z comes out to 1.58. So we'll go to table 5 and look up that value. Here's 1.5, here's the 8, looks like it's about here, 1.5 and then the 8, 0.9429, but again, like before, remember that 0.9429 represents the area to the left, and we're trying to find the area on the right side, so we'll have to do the complement. And that's going to be 0.0571. So that's written out right here. We did the complement. We get 0.0571. So either way, we get that result. These results, again, are a little different from each other, but it's okay if you get those different results. Part C is very similar to Part B. The only difference is that now we're taking a sample of 20 customers. They say, what's the probability that a sample of 20 customers results in a mean wait time of more than 12 minutes? So we're dealing with another sample. This time it's 20 customers. We're still talking about the mean wait time. We're dealing with the sampling distribution in this case. And so that means that we're going to have to recalculate the mean and standard deviation. The mean is still 10.4, but the standard deviation, it will change again. So it's still the population standard deviation, 3.2, divided by the square root of n, which is now 20. And it works out to about 0.716. So with that in mind, we can use either method. We can use a graphing calculator. If we did the graphing calculator, we could still draw out the normal curve if we wanted to, if that helped out. It's the same as what it was before. We could use the Casio or the TI calculators. And the only difference is that when using NCD now, the standard deviation is smaller because our sample size is larger. So we put in 0.716. On the calculator, still use normal CDF, but again, the only difference is the standard deviation is now smaller. And so that probability is going to be 0.0127. The other way to work this out is again with the table 5. We could draw out the normal curve. Calculate the z-score. Use this z-score formula for sample means. Plug in 12, 10.4, but now this time we're plugging in 0.716 for the standard deviation. And the z then comes out to 2.23. So go to table 5, look up 2.23. Here's 2.2, and here's the 3. So it lines up about here. 2.23. 0.9871. But as you can probably tell by now, that 0.9871 represents the area to the left. And we want the area to the right for this problem, so we'll do the complement. So that's going to be 0.0129. And so that's worked out right here. Did the complement, got 0.0129. And so that is our result. Slightly different, again, depending on whether you use a calculator or a table, but that's okay. They're about the same. All right, in the next video, we'll take a look at the rest of this problem.